Okay, this is the Notes 2.6. We started this yesterday or the day before, and this is what you have written down right now. I just want to quickly review it with you, and then we'll continue from here. This one's kind of long, that's why it's separated into two videos. Take your time. It's a lot of writing down, but we did a lot. We're going to do a lot of examples too. Okay, so this is the first thing, Notes 2.6 with the functions. We reviewed that you have seen things with two variables before, namely points. Every point you've ever seen has two parts to it. That was the x and the y. And we also reviewed that the x has some fancy names for it. So it's not always going to be an x and a y, but generally the first one you're given in a pair is called the independent variable. And it is also a member of something called the domain. And remember, those are just fancy ways of saying the x, or the first variable. The y, the second number, is the dependent variable because it depends on what the x is. It's also a member of something called the range. And remember, those are just fancy words to say the y. So again, we use these words interchangeably when we're talking about functions. Generally, we're going to use these big fancy words, not the x and the y, but use all that stuff. Okay. So where do we go from here? I'm going to give you a set of points. So let's say I give you negative 2 and 3, 3, negative 1. I basically want to just explain the domain and the range some more, so you get the idea. Let's say I have these four coordinates. Negative 2, 3, negative 3, negative 1, 5, 0, and negative 4, 3. Remember that each one of these is composed of an x part of the coordinate and a y part of the coordinate. And I can describe the domain and the range of this complete set of points. It helps if I draw a table. Right, a lot of times when you found points, you made a table. I'm trying to remember last year. But if I was to list each one of these as a coordinate in a table, so like the first one, this would be negative 2 and 3. I'm just taking the x and the y from this first point and putting them in the right column. The next point, 3, comma, negative 1. The next point is 5 and 0. And then the last point is negative 4 and 3. The table's not like this. All right. So this is a table. All these are points. They all go together. Right? If we put parentheses, you get the first point. Put parentheses, that's the next point. So now if I was to refer to these as domain and range. So if I was to describe the domain of this first part, all right, so the domain of this set is just going to be the x's. All this stuff on the left, that's the domain. So if I'm talking about the domain of this, I'm just going to list off the x's. So I use curly braces because I want to be fancy. I'm using fancy words, so I'm using fancy braces. It's also used to denote a set of something. But so the domain of this is negative 2, and then 3, and then 5, and negative 4. Right, I'm just listing off the x coordinates of all my points. Those are all the members of the domain. It's like all of my x's. Fancy word for x. The range, super similar. If I want to list the range of this set of points, all I got to do is list off all the y's. That's all these things right here. All the y's. So the range for this set of points is 3 and negative 1 and 0 and 3. Yay! So the domains for this set, negative 2, 3, 5, and 4. The range is 3, negative 1, 0, and 3. The reason to give you this is our definition of a function is using the domain and the range. So this thing called a function, this is the important part. We'll write this down and we're going to spend the rest of the time trying to explain this or prove it. So what a function is, it says that each element of the domain, so that's like every x, so each element of the domain has one and only one element in the range. So if you need to pause it to write all that down, you can, but I'm going to keep battling on. It says that everything in the x is only paired up with one thing in the y's. So all these domains, all these members of the domain, they've only got one partner in the y. Okay, again, if you need to pause it, you can, but I'm going to keep going. So what does this mean, and what does this look like? I gotta say, I give you a set of points, or a mini table here of x's and y's, and then I say the domain is -3, 6, -3, and 8, and the range for this is -5, 7, 4, and -2. I want to know, is it a function? Does every member of the domain have one and only one matching element in the range? Again, pause it, take 30 seconds, decide, is this a function? Yes or no? It's a yes or no question. And then, like, if you say yes, how come? If you say no, how come? Or pause it, come up with an answer, and when you're ready, unpause it. Okay, this one is not a function because if you look here, I got a -3 going with -5, and then down below, you got a -3 and a 4. So it's like saying -3 is going out with -5, and it's also going out with 4. It can't happen. You have one element of the domain. It's going with two elements from the range. Okay, that's not cool. You can't be going out with two different people. It's like saying you like Taylor Swift, and then you also like, I don't know, Demi Lovato. You can't do that. You got to pick one or the other. It doesn't matter backwards, right? Does it matter if Demi Lovato likes you or if Taylor Swift likes you? No. It does matter, though, who you like. So every domain can only have one element in the range. I'm going to put 3 down here right underneath it. 3 little examples. Example 1, 2, and 3. And they're going to be little sets of points like this. And after you're done writing them, pause the video and tell me, yes or no, is this a function? So let's see. 11, -2, 8, -2, 6, 1, 4, 3, 4, 3. And remember, all a function is one thing from the x has exactly one matching thing in the y. Example 2. Example 3. All right, if you've written it, pause it now, write it down, and decide yes or no are these functions. All right, so the first one, yes, this is a function. Every element of the x has one matching thing in the y's. Every domain has one matching element in the range. 11 and negative 2, 8 and negative 2, 6 and 1. It's okay here that these are both having negative 2 as their range. It's just saying 11 likes negative 2, 8 likes negative 2. That's okay. Two people can like the same person. You just can't like two different people. Like down here, 4 is with a 3, but then 4, it repeated itself, but hey, it's like asking, hey 4, I like 3. Hey 4, who do you like again? Oh, I still like 3. It's okay. 4 and 3 are going together and it's not changing. The second one is not a function, and hopefully you saw why. Right here, 8 and 1 are together. And then if you ask 8 again, all of a sudden it's, no, I like 8s and 9 are together. And that can't happen. That's confusing. Mathematically, it's confusing. Relationship-wise, it's confusing. But here you got the same domain going with two different ranges. So that can't happen. That is not a function. And then finally, the third one. Yes, this is a function. All right, 1 likes 1. 3 also likes 1. 5 likes 1. 7 likes 1. And what's weird is if you go back to the beginning, who does 1 like? 1 likes themselves. But everybody loves 1. That's okay. Every element from the domain has one and only one matching pair or partner in the range. So it is a function. You got nothing weird like this bottom part, the middle one happening. All right. The next video has the next section where we talk about what does this look like in a picture form. What does a function look like, and what does stuff that's not a function look like? Like pictorially, how do these things change? All right. So when you know this, go to the next video on notes 2.4 functions part 2.